Hey guys, ready for some totally original content, never ever done before by mankind. Oh crap, those videos are fake. Well, technically they built an AI that could beat Tic Tac Toe, but the AI never actually learned. Instead, the AI instantly started playing with mastery. Before I go forward, if you just want to see my AI, skip ahead here. Also, if you want to play my AI, it's the first link in the description. Returning back, those videos use something fancy called the Minimax Algorithm. The almighty coding train can explain the algorithm a lot better than I can. But to keep it simple, you start from the current board layout. Let's say this. The algorithm then envisions the immediate possible moves. So here, you could draw an X at any of the side spots. Then, from each of those potential board layouts, it again calculates the immediate possible moves, and so on. The cycle ends when each of the possible games end. Then, to pick the best move, it simply counts up the number of games it won after doing each move. So here, let's say the AI played left corner, then that resulted with 30,000 wins, 20,000 losses, and 10,000 draws. So the AI simply picks the moves that has the most wins at any board layout. You may wonder, how big will these cycles or trees become? Well, put your math hats on or just mute the next few minutes. If you start with 9 initial moves in the beginning, then in the next move you will have 8 possible moves, as one of those spots are already taken. Then, after that you'll have 7 moves, then 6, and so on. So, in the beginning there is 9 initial moves, then 8, then 7. So, to calculate the number of configurations, you simply multiply each number of possible moves, so that would be 9 times 8 times 7 times 6 and so on, or just 9 factorial. This results with a maximum of 362,880 configurations. However, it's important to realize that you could win the game without fully filling up the board. So, 362,000 is an overestimate. For that reason, the actual number of possibilities is around 250,000 or so. The AI can easily calculate millions of possibilities. So a mere 250,000 is child's play. But that algorithm is lame, mainly because the AI doesn't actually learn anything. Instead, it just followed a set of rules. That's like if a noob, who only knew the basic rules of tic-tac-toe, makes the big brain play instantly and thinks a billion moves ahead and calculates the best path. So when we play tic-tac-toe, we value how good each board layout is. For example, if I'm circle and it's my turn, this board will be super high in value, as we're literally gonna win next turn. Then again, on this board, we have to value which move is the best. Again, playing the corner is the best move because we're going to win. Now the question is, how the heck is the AI going to figure out how good the board is, and specifically how good each action in the board is? You know what? Future me will figure that one out. Let's first build a working tic-tac-toe game. Oh wow, with the power of editing, we have a board, and I can click around to add circles anywhere. Easy. Wow. Okay, then I coded in a check that just makes sure anyone won or lost. It works sometimes, I guess. So, I fixed it. That took way too long than it should have. So it just prints out true if the player won, and false if the AI won. Time to code the AI. Yeah, you know what? Hey look guys, I added some pretty buttons to the game. Okay. Let's actually start the AI. So this AI is going to use something fancy called Q-learning. Before I delve into the abyss of Q-learning, we need to talk about motivation. If Billy's mom wants him to clean his room, she needs to either motivate him or, like many Asian families, punish him. Billy's mom could motivate Billy by giving him an enticing reward, so Billy's mom can let him play Minecraft if he cleans the room. Or, Billy's mom could punish him by throwing his computer out the window if he doesn't clean it. Oh, that brings me back to my childhood. Was that just me? Similarly, if we want an AI to actually win, we need to motivate it. And what motivates AIs? Positive numbers. AIs go crazy over positive numbers. In contrast, the AI would rather shut down and die rather to see some ugly negative numbers. Now that we understand that, let's jump into Q learning. The most important part of Q learning are the Q tables. Yes, I know, flawless naming scheme. A Q table is just a chart of how good each action in a board layout is. So here, a filled out Q table may be like this, where each action is represented by a number. Then, the AI simply picks the largest number. Now, the tricky part is how the AI fills out the Q table. But let's worry about that one later. Future me will handle it again. So, let's code a method that picks the best action based on the info from a Q table. Now again, we will fill out the Q table later. So, to just test out this method, let's hard code the positive number 100 into the second and third row of the first column of the Q table. Then, if I run the code, you can see the AI alternates between picking 1, 0 and 2, 0. The first number are the rows, and the second number are the columns. Imagine counting from 1 like peasants. Now we nerds count from 0. So 1 is actually row 2. So basically, the AI is correctly picking to move to the second or third row of the first column because the Q table have the largest values in those two indexes. So for the time being, let's make a bot that just randomly moves to any open spot in a board layout. Or in other words, each board will have a Q table of 0 at every spot. So the AI just randomly picks a spot. Oh crap. So the AI has evolved. It learned how to put pieces on top of other pieces. That's the biggest brain play. Okay, that's an easy fix. On the Q table, if a piece already exists on that spot, let's give that spot a Q value of a super tiny number. Let's just say negative infinity. Okay, so I fixed that. And we have an AI, or more specifically just a bot, that follows the empty Q table and randomly moves around the board. Okay, so we actually have to figure out how to fill out the Q table. This will make it so the AI actually moves to the correct spot each time. So, when the game starts, let's set the Q table for every board layout to just be a bunch of zeros. This shows that the AI doesn't know anything, and in the beginning, the AI will just randomly move around. Now, we need to understand three things: the state, the value, and the reward. So let's say we have this board. We call a board layout just the state. Then, the AI can put a piece anywhere on the state. The location of the piece will be called the action. For example, an action could be 0, 1 for the top center, or 2, 2 for the bottom right corner. Then, after putting the piece, we need to check if someone actually won. This is called the reward. So, if the AI puts a piece on the bottom left corner, the reward is going to be an enticing positive 1. Now, similarly, if the AI's opponent wins directly after the AI makes an action, then the reward will be an ugly negative 1. So, let's say the AI screwed up and moved to the top center spot. Then the AI's opponent stole the win by moving to the bottom left corner, so the reward will be an ugly negative 1. If nothing happened, meaning the game hasn't ended, the reward is a regular 0. So if the AI moved to the top middle, then the AI's opponent moved to the right corner, so the reward will be 0 because no one won or lost in that turn. Lastly, if the board gets completely filled, resulting with a tie, the reward will be a 0.5. Now, let's say we have the following sequence of moves. State 0 is an empty board. Then the AI moved to the center. Then the AI's opponent moved to the top left, resulting with a reward of 0. Then, the AI makes the action center. The opponent responds with a bottom left, and the reward is again 0. Now, pause if you have to, but what is the best move for the AI? Yeah, for humans, the winning move is easy. So let's say the AI played the correct move and moved to the center right and won. So the reward is positive 1. We store this sequence and work back to update the Q values. So action 2 immediately led to a victory. So we should value that move really highly. Let's update the Q value for that action as a hot positive 1. Now let's look at action 1. That move doesn't immediately lead to a victory, so that move is mathematically worse than action 2. But that move leads to winning in the next move, so it's clearly a good move. So let's give it a 0.7. There is a more specific formula called the Bellman expectation equation that gives us the exact number. But this is the basic gist of it. Then, action 0 has to be mathematically worse than action 1 and action 2. But it's not bad, so let's give it a 0.6. Now, let's go over another game. Now, pause the video and see if you can understand this sequence. Let's work backwards. Action 2 immediately leads to a reward of -1, so we can update the Q table with a -1 for that action. Now this makes sense, as the AI should be slapped around if it's so stupid to move to a spot which will make it lose. Now action 1 isn't necessarily a bad move, actually it's a good move, but mathematically it led to the AI losing in the next move. So we need to value action 1 a -0.8. So again, mathematically it's a bad move, but not as bad as action 2. Going back to action 0. We moved to the center, and that led to us losing 2 rounds later, so let's give that spot a value of -0.6. But wait, if you remember in the previous game, we valued moving to the center positively as +0.6 because it led to us winning 2 rounds later. So now we need to pick which number we want to save, 0.6 or -0.6. We just end up averaging the two numbers together, so after those 2 games, the spot has a Q value of just 0. If you keep doing this process over and over again, you will be able to visit every state and do almost every possible action. Again, there are only 250,000 moves, which is absolutely nothing for an AI. So, if the AI does it over and over again, it will be able to get a good value for each action and fill out the Q table. I also wanted to mention I used a slightly modified version of this process, but it follows the same core ideas. You know what? If I get 20 likes, I'll make a video where I explain my modified version and delve more into Q learning. So let's see this AI. Initially, the AI is in generation 0, meaning the Q table is just filled with zeros. So the AI will just randomly move. The AI is pretty stupid right now. Let's train it for a bit. After 2000 games played by the AI becomes super good. So the AI here is X, and I am literally struggling to beat my creation. There may be some occasions where you do win, but if you let the AI train for longer, you won't be able to beat it. Now let's train it for a bit longer while I go eat some lunch. Okay, so now we are at 12,000 games played. Again, the AI is now borderline perfect. I added a dope option called Show Values. This shows the AI's Q table after making each move. So right here, the AI moved to the top center. Its Q table value was 0.80, which is bigger than the other numbers, which is why it moved there. Now I take an action, so it moved to the top left center because that spot has a Q value of 0.81, which is the largest. Again, in the description below, you guys can train and play the AI yourself. So we're done here, guys. Most of you in the previous video asked for a longer video that goes over more math, so I hope this works for you. If you have any more feedback, just hit me up in the comments. I will respond to each and every one of you guys. So it took me like 2 weeks to code this baby up, so a like and a sub would be really appreciated. So see ya, guys.